Hello friends, welcome to my channel. Let's have a look at some newly appeared problems. First, let's have a look at problem 2610. Convert an array into a 2D array with conditions. In this video, we're going to share a solution based on the help of the dictionary data structure. First, let's look at the problem statement. So we are given an integer array called nums. We need to create a 2D array from nums satisfying the following conditions. First, the 2D array should contain only the elements of the array nums. This is the source of elements of the 2D array. Secondly, each row in the 2D array contains distinct integers. So this is distinct elements in each row. And third, the number of rows in the 2D array should be minimal. We are required to return the resulting array, and if there are multiple answers, we can return any of them. So actually, if there is a solution, then we can do some permutations of the rows. Therefore, in such a sense, the solutions are not unique. Also, within one row, so we can switch the orders, right? So here, note that the 2D array can have a different number of elements on each row. So this actually simplifies the problem, right? So here are some examples. In example 2, so this is very special because this array or list contains unique elements. Therefore, we can just return a 2D array consisting of only one line. That is the nums array itself. So this is example 2. In example 1, so there are 1, 2, 3, 4. These are the 4 unique elements, but 1 appears 3 times, and 2 appears once, and 3 appears twice, and 4 appears once, right? So the result here is an 2D array consisting 3 rows, and the longest row contains 4 elements. Notice that these 4 elements are exactly the maximal frequency of the unique numbers. That is, here the 4 is actually the distinct unique numbers. So there are 1, 2, 3, 4, right? So the constraints for this problem are the following. First, the list nums is not empty and it's bounded above by 200. So this is actually a small number. So this 200 actually defines the problem size upper bound. And secondly, so nums I, or the elements, is greater than or equal to 1, less than or equal to the length, right? So basically, this means that we might have multiple occurrence of unique elements, right? For example, here, so the 1 appears 3 times. So so the length here is 7, right? 4 is less than 7, right? So with that said, we are ready to look at the analysis or strategy. So here I'm going to explain a solution based on the help of the dictionary data structure or hash map. So the strategy is very straightforward. So we can build a 2D array such that each row contains the available unique values in the given list nums. So let's have a look at this example 1. So if we count the occurrences of the unique numbers, so 1 appears 3 times, 3 appears twice, 4 appears once, and 2 appears once. So there are 4 unique values. So in the and the largest frequency is 3. So we are going to make a 3-row 2D array. Here the 3 is the largest frequency or occurrence. So for the first one, I'm going to pick all the unique numbers. So we have 1, 3, 4, 2, right? Then we're going to decrement the counting by 1. So here now 1 appears twice, 3 appears once, 4 appears 0 times, 2 appears 0 times. So if the occurrence is 0, so we just ignore that corresponding key, right? And then we can choose the unique case, that is 1 and 3. So we get this row 1. So then the occurrence of 1 is decremented by 1. So we have it appears once now, and 3 appears 0 times, and 4 appears, and 2 remain 0 in frequency. And then we have a unique values, that is 1. So we put 1 in row 2. Then its frequency is 0 now. Then basically we get 1, 3, 4, 2, 1, 3, and 1. So this is the one possibility. So to sum up, right? So the longest row actually contains the number of unique values, right, in the original 2D in the original nums array. And the number of rows in this strategy is the largest frequency. For example, this one, the largest frequency is 3. So we have 3 rows. So this is one point we want to make. And another point I want to make is that so the 2D array by no means is unique. So for example, we can switch the 3 rows, right? Within each row, we can switch the corresponding elements, right? So it's in such a sense, it's highly non-unique. So with that said, we can transform or translate the above strategy into code. So here, in order to make it more clear, I'm going to write with some redundancy, right? So first, I'm going to get the dictionary, or I can use the collections counter, right? So this accepts a iterable or sequence, and then it gives us the unique value and its frequency, right? So this is the dictionary, right? And then we can get the unique values for now. That is count. Let's see, keys. So we can make it a list, right? So this is the one thing, right? So the length of this case actually is the number of unique values in the original nums array. And also we want to get the number of rows. So number of rows will be the max of the count frequency, that is the values, right? And then we can construct our 2D array. So here, let's see, this is step 0, preparation. And then let's do the main step. Let's call it step 1. So this build the 2D array according to the above strategy. So this is very standard. Let's initialize a result variable. So this list is going to hold each of the rows, and then we're going to return the final state of this result variable. Then we're going to iterate. So for I in, so actually we don't need this I. Let's use for a dummy index in the range n rows, right? For each row, we're going to build a corresponding list. So let's call it temp. And then what we are going to do, we are going to iterate over the keys, right? Notice that on this problem, the length of this guy is very small, right? So also we have this, the second constraint. In other words, the number of unique values is bounded above for sure by 200. So now let's iterate that. So for k in keys, what we are going to do, we are going to check if count k is greater than 0. Then we're going to add the corresponding key to the temp or to this row, and then we're going to decrement this by 1. So let's do this. Temp append key, and then the corresponding count of the key is decremented by 1. So this if condition also says that if the count is 0, so we do not append anymore, like here, right? So this is the main logic. So after this for loop, in other words, we iterate over all the keys, right? So we're going to append the temp to the result. So this way of writing actually is sort of verbose, because in the process, some of the keys will have 0 occurrence. So actually we can actually update the keys, right? If we use the keys as a set, and then afterwards, if it's 0 occurrence, so we pop that corresponding key. But for this problem, we will content ourselves with the current format of writing, right? So even if we want to make an effort to do that, that's also very straightforward. So now, step 2, do the return. So this, we just need to return the state of the result. So now this short snippet forms a solution format for this problem. Before we make any comments, let's do a test. Yeah, it passes the first example, right? So let's check for the generic case. Yeah, it passes all the generic cases. So I guess for this problem, so once we realize how to organize the unique values in the nums array, so we have a number of ways to build the 2D array. So here we provided just one of them. So with that said, I guess that's about it for this video. If you are interested, you are welcome to follow up in my YouTube channel. So with that said, I guess that's it. Thank you.